The demo will be a very simple application, a contact manager application that will allow us to see our contacts, add new contacts, and delete them too. So, normally to start a play application, we would usually do play new in the name of the application. But for this occasion, we have prepared a quick start module to make it easier. So, let's have a look at it. This is the quick start module, right? We just follow the steps. That's right. This is the quick start that we were talking about, and we're just going to follow the steps. As you can see here, we have to create a new Openshift application. Let's do it. We're going to name this application Contacts. It will be of type do-it-yourself application.
It seems like we're having a bit of delay, so bear with us.
While the application is being created, I'll talk to you a little bit about this quick start. The quick start is just a basic Play 2 application for Java. What you can see here is the common structure of a Play application. Now it's asking for my GitHub keys, so I'm going to enter my password. Openshift has created for us a Git repository on the cloud, and now it's cloning it on my workstation. The quick start itself, as I was telling you, is just a basic Play application with a couple of scripts to make it easier for us to deploy it on Openshift. Right. Now we'll go on with the next. We are going to add our quick start as a remote repo so that we can fetch its contents. There we are. Here you can see this is a plain application for Java with the scripts I told you about for Openshift. Well, now we are ready to deploy it. We are going to use our convenience script that we prepared. But usually deploying a Play application is as easy as play stage. It's the command that we tell Play to prepare the deployment, to package the application for deployment, and then the usual Git stuff, Git add, Git commit, Git push. This little script that make it easier for us. The first time it will last a couple of minutes because it has to upload all Play libraries, but you see that other pulls will be much faster. In the meantime, we're going to have a look at this application. Well, we're going to start Play Console. The Play Console allows us to work with our application. Right now, we are going to run it. Play is now starting our application. Play comes bundled with an integrated HTTP server that is now it's listening on port 9000.
One thing to notice about Play is when you download it, it's a full stack framework. This means that everything you need to start developing new applications is right there. Just downloaded that zip file from the Play framework page gives you everything. Of course, you can add things later, but everything you need to start is there. Even an in-base an in-memory database that you can start using right away. We
have a little delay here, but we are waiting for the basic Play application to show up. We just have to go to our local host, to the port 9000, and there we will see our application up and running.
And there should be a browser with the application right now. I think it's not getting refreshed there.
I guess we lost connection. Well, this is Play Framework welcome screen. There is a great delay in the connection. We're going to see if we can solve this. We had it almost a minute ago already. This welcome script just tells you how Play managed to show you this screen. Basically, it goes through a basic flow in which the HTTP request comes to the server and is handled by the server itself. Well, now we're going to have a look at the basic application that we downloaded from the Quick Start. Here you see the structure of a Play application. Play implements the MVC controller, so here you have in the app folder, a folder for the controllers, another folder for the views, and you also have your model here. In the app folder you get the source code, your server executable files. That is your Java controllers, your Scala controllers, and also your templates. In the conf folder, we have the configuration of our application. This Openshift.conf file was added by our Quick Start, and it let us further customize the configuration of our application when it is running on Openshift.
Yeah, as you can see, Playmore is an MVC framework, so basically you have to think of your controllers, your views, and your models and how you connect them all. Something important here as well in this directory is the root file. The root file is a file where you can specify what URLs are available for your application. The syntax is very simple. As you can see, in the first line, for example, we have a root that gives us the home page. And this line is saying that whenever the application gets an HTTP GET request over the /URL, it has to call the method index in our application controller. And that's the way you do the mapping between the URLs that you need and your controllers. And now, we're going to jump to the application controller and show you what it looks like. The application controller, as you can see here, is a simple Java class that extends controller that comes from the framework. And every action that you want to invoke is, as you can see, is a static method in the controller that returns a result. That result translates to an HTTP response that can be an OK response, a byte request, or whatever. And what you pass to that response is the thing that you want to display in the browser, where the templates that the framework comes in.
Well, the template is based on Scala, but as you can see, you don't have to be a Scala guru to be able to work with them. It's pretty simple, the syntax. Now what we're going to do is modify this basic default template that comes with Play, and we'll just I modified the template, just save it, and now I can go to my web page and see how it looks like. You see, I haven't redeployed my app. I haven't had to stop or restart any server. I don't have any complex IDE building the redeploy for me on the background. I just modify the source file, go to the browser, hit refresh, and that's it.
Yeah, that's one of the things that the Play framework developers wanted to do with the framework. They wanted to give you a quick turnaround so you can just focus on the code, do your changes, and click Save, and then come back to the browser and reload, and you should see all the results.
But what happens if I make a mistake? Let's say, for example, that instead of passing a string like the template is expecting, I pass a number.
Let's go to refresh.
There you are. Right there on your browser, you can see the error. It tells us that the method render expects a string. Instead, it got an int. And it also tells us which is exactly line of code where we should fix it. We're going to fix it.
This is a very nice feature. Everything you have in your Play project that includes controllers, root files, or configuration is checked all the time, and they will reload them if you change anything. Even if you have a syntax error in your root file, it's going to show in the browser. So that's pretty handy when you reload it.
So you could go on working just with a simple text editor. You don't need a complex IDE, but if you're used to, why not take advantage of it? So that's what we're going to do next. Go to the console.
Play comes with support for Eclipse and IntelliJ. You can generate project files for those IDEs very easily. And to do that, you just go to the Play console and type a command that will analyze the project and create the module files for it. So that's what we're going to do now.
Right. I just entered the idea command in Play console, and with that, Play created all the files I need to be able to work with my project on IDEA. I restart the server once again, and then I open the IntelliJ IDEA IDE. You can also work with Eclipse, as Jorge has said there.
We're going to create the Play project now.
We select a new project from scratch. Tell IDEA that we don't want to create a model because we will use the model that Play has already created for us. And now we're going to just import that model. That's it. And finish. Okay. Well, here you have the same application that we were working with. The first thing we'll do to modify our routes file. So we go to the conf directory, we open the routes file, see the default routes that they create for every application. And here the new set of routes that we will use. We will use, whenever our application gets a get method to the contact resource, it will be handled by the contact action of the application controller, and so on. Well, let's see what Play thinks about it. We just head to the browser, hit refresh, and there you are. Play is telling us that in our routes file, we are referencing an action that doesn't exist. So as you can see, routes file, I also typeface. They are compiled, so it's very easy for you to catch when you break something. Well, let's fix it. We open controller.
Yeah, you should be seeing the controller anytime now. We're going to replace it all the code that we had before with any methods for our controller.
Luckily enough, we don't have to implement every action right now, but we do have to tell Play that we're going to do it. That's what we do when we return us to do. And now we can see it in action.
We go back to the browser and we hit reload, and we should see that the URL is working, but we still don't have any implementation for it. So there you go. Now we go back to the browser and we're going to make some changes.
That's right. We create a package model, and then we create a new class for our contacts.
Play 2 comes with EBIS, which is a systems framework that is very suitable for stateless applications, because one of the things that Play was designed in mind to was having stateless applications, because it allows us to scale better. So when you're building applications in this framework, you have to think that you have to process your requests and don't keep state on the server. I mean, in the Play framework, you don't have anything like the servlet session in the standard Java stack, and not having this session on the server side makes your applications easier to scale. So the EBIS library is not suitable for this kind of application. You do have JPA annotations, so that's what you're seeing on the screen right now. You create your entity, and then you can annotate attributes with the required things for your model.
You just have to implement a finder middle, as you can see. And for this demo, we've also implemented 3 very simple methods. One, to get all the list of contacts, another to create a new one, and finally, one to delete. And as you can see, the code is very obvious. So now, we're going to implement the contact action, right? For this action, we have to return the list of the existing contacts, and we'll also return a form the user add a new contact. So, first of all, we declare a form that will handle the HTML form that will be posted to the action. That's it. And then we modify the contact action. As you can see, we are returning a 200 HTTP status code, that's the OK, and we are rendering the view index.render, passing the list of contacts and the contact form that we already defined. IntelliJ is already telling us that there's something wrong there. So, let's see what Play thinks about it. Well, we'll go and fix the template.
Okay, so let's see what we're going to have in this new page. Form on the top with 2 fields, one for the name and one for the email address of the contact that we're trying to add. And then we're going to have a submit button to send the new contacts to the server. And below that, we're going to make a table listing all the contacts that we have added so far. And next to each contact name, we're going to have a delete action to delete them. It's a very simple. It's a very single app page.
And as you can see, Scala is no problem because you are issuing decisions, loops. You shouldn't do anything more complicated. But if you want to, you have a full feature language like Scala. So let's see this in action. We get back to the browser and hit refresh. And Play is telling us that we haven't configured a data source yet. So we're just going to go to the configuration file. And for this demo, we're going to tell Play that we'll be working with an in-memory database.
Let's see. So we go back to the browser and refresh. And what Play is telling us right now is that it found new changes for our database, and it's telling us that our database needs to be upgraded. Every time you do changes that is in development mode, Play generates called something evolution that's going to apply changes to your database and update it to the latest changes. So now we're going to apply the script that should create the in-memory database for us. And that's the form that we have right now. As you can see, we have the 2 fields we set, and we can just start adding contacts right away. But oops, we have the to-do result there, so we haven't implemented that. Let's complete that pretty fast. The nice thing to see here is how the development process goes, right? It's like you change your application, you go back to the browser, hit refresh, and come back. And that gives you a very nice development to work with.
Yes, for this demo, we prepared something like an error-driven development. every error that gets caught at play is telling you what's the next. Here we implemented the new contact method. We're just declaring a form that will take care of the HTML posted values. And if the form has errors, we just taking the user back again so that he can fix the errors. And if everything is okay, well, we just create the contact and issue a redirect to our list of contacts.
Yeah, you can see how easy it is to parse a form. We didn't have to deal with the fields directly. We just said that the controller was using a form based on the contact class, and then yes, pretty handy. We just online parsing the request and knowing if there are any errors. How does the form know if we have errors on it? It's taking the annotations that we have on the model class. So it's using them to detect if we have errors or not. And as you can see on the screen, for example, for name, it's telling you that it's required. That comes from the model. And also, it's telling you that the second field is required, and it's an email address. And if you have an error, it's going to tell you that you have to enter a valid email. That all comes from the URL in the model.
Well, now we are ready to add our contact. We just hit add contact, and there it is. We have one contact in our database. That's it. For the deletion of contact, we're going to do something a little more involved. We are going to create a Scala controller. We'll name it Scala application.
This is just to show you that you can combine those two languages. Play doesn't impose the use of either language. You're free to choose what to use regarding to your controllers. True that the templates are written in Scala, but as the templates are not supposed to have a lot of logic, they're just for presentation. The syntax, the Scala syntax that we have to learn to make them is very simple. But it's nice to see a Scala controller because the API is very hot. And if you have been using Java with Play, and then you switch to Scala, you're going to find that the concepts are the same. Many of the API calls look similar, so the transition is very easy.
In this example, we can see that it is a little more functional, the Scala API style, yes. But the important thing here is that we are using the same model that we use in Java. It's the same contact. We are using also the same template. We are even using the same routes. So it's really easy to combine both languages. Well, now we're going to get rid of our dummy implementation. That's right.
Yeah, we don't need that action in the Java controller anymore.
And we'll let Play tell us what to do next. So we'll go to the browser, hit refresh. And there you are. Play is telling us that the action no longer exists in the log file. So once we just press, we'll get back to the browser and hit refresh. Well, now it's telling us that there's something wrong with the view, and it's right. So we just fixed it.
Yeah, we're still referencing the old controller. One thing to note here is that this is a simple demo, and we're using get HTTP call deletion. The right way to do it would be to issue a delete request, but since we're doing this pretty fast, we're just using get. Ideally, you would issue an Ajax call with a request, delete request to take care of that.
Well, now we're going to delete the contact and Just click on delete, and there you go. Our application is now fully functional. All the requirements that we had are already developed, but it doesn't look so nice. So we're going to just style it a little bit. For this, we're going to copy the Twitter Bootstrap sheet. That's it. We get rid of the other style sheet.
Play comes with a public directory where you can place all your static files like images, JavaScript, and style sheets. So I recommend the layout, but you can of course change it if you want. Okay, we're going to update the HTML file.
That's it. Just put in there some styles and static stuff in there. So let's see how it goes.
Okay, that looks a little bit better now.
Well, but we have a problem here, is that Play automatically builds the layout for the input, the default layout. We're going to have a look at it. Well, and we are going to replace it with our own implementation. So we'll just create a new template, which will be called.
I'm going to ask just the remaining file. We should be set. Okay, there you are.
We're just creating a template that will take care of the input layout, something compatible with the Twitter Bootstrap style. We'll just update the index file, and that's it. A whole lot better. Now we're ready to deploy it on Openshift. But first, we have to make one more change, because right now we are working with a in-memory database, and we really don't want to do that on Openshift, right? The problem is that if we work with an in-memory database on Openshift, every time we push, the server is down, so we would lose our data. We will modify the Openshift configuration file to tell Openshift to save it to the file system. And now, yes.
So we're going to deploy again. Going back to the terminal and deploy again.
That's it. We're just taking the template openshift.conf file, and we are uncommenting 2 lines that tells Openshift to save the database in the file system. That change, we are ready to deploy our application to Openshift. Right? We are deploying, and at the same time, in the lower part of the screen, we'll have a look at the logs of the application. That's it. Play is preparing the deployment. We are logging into our browser to have a look at the log files at the same time. Here you can see that on Openshift, the application has started on production mode. Running on production, everything is compiled, so there's no hot reload when you're running on production mode. And you can also see that the application connected file database. This is our local app. Now we're going to open our remote application on Openshift. We've already done that. We're looking at it at our screen, but unfortunately there's a huge delay in the connection, so we're pretty sorry for that. But I hope that in a couple of seconds you may have a look at it. That's it. You can also open your browser and go play with it right away. It will be faster than if you do it from here, I guess. So that's it. We have deployed a Play application on Openshift.
Yeah, that's I have to show you today. Thank you.
Thank you a lot.